Welcome back to Mysterious Universe, the channel where we unravel the most puzzling questions of science, space, and the unknown. We've gazed into black holes, danced on the edge of solar flares, and wondered what would happen if the sun exploded tomorrow. But tonight, we're turning our attention to something much closer, something that stares at us every night, watching. The moon. It lights our skies, pulls at our oceans, and may have shaped life itself. But despite decades of space exploration and countless missions, the moon remains a vault of unanswered questions. From strange magnetic fields to unexplainable seismic activity, from hidden mass anomalies to the eerie origins of its formation, the moon is far more mysterious than most people realize. In this video, we dive into 10 mysteries about the moon that scientists still can't explain. Some might make you wonder if we really know our nearest neighbor at all. So if you're fascinated by cosmic riddles, lunar legends, and the frontiers of space science, hit that subscribe button, tap the notification bell, and stay with us until the end, because this moon story might just change the way you look up at night. Ready to explore the unknown? Let's begin. The prevailing theory of the moon's origin is the giant impact hypothesis, that a Mars-sized object named Theia collided with the early Earth, hurling debris into orbit that eventually coalesced into the moon. On paper, this explains many things: the moon's size, orbit, and composition, but recent studies show that lunar rocks are almost chemically identical to Earth's mantle. Too identical. If the moon came from a different planetary body, it should have a distinct chemical fingerprint. This has led scientists to propose alternative theories: a double planet formation, where Earth and Moon form side by side, or a vaporized synestia disk collapsing into two bodies. But none fully explain the similarity in isotopic ratios. Could Theia have had an identical composition to Earth? Could Earth have once spun so rapidly that it shed material into orbit on its own? Or is our understanding of early solar system collisions deeply flawed? We may never know for sure, unless we can sample the moon's deep interior. Until then, the moon's very existence remains one of science's most elegant puzzles. One of the moon's most perplexing features is the stark contrast between its near and far sides. The near side, the one we see, is covered with dark, flat plains called Maria, formed by ancient volcanic activity. But the far side? It's rugged, mountainous, and strangely devoid of Maria. Why such a dramatic difference? One theory suggests it has to do with Earth's gravitational influence. The Earth-facing side was kept warmer, allowing magma to flow more freely and create lava plains. The far side cooled faster, remaining rugged and inhospitable. Another theory proposes a massive impact on the far side early in lunar history, which reshaped its crust. Some scientists even think the moon may have had a companion, a second moon, that later collided and merged, causing crustal thickening on one side. But none of these fully explain why the crust on the far side is thicker and more elevated. It's a lopsidedness that defies easy answers. We've mapped the moon's surface in exquisite detail, yet this basic asymmetry remains a cosmic enigma. Today, the moon has no global magnetic field, yet rocks retrieved from Apollo missions show they were once magnetized, indicating that billions of years ago, the moon had a magnetic field nearly as strong as Earth's. But how, and why did it vanish? Scientists theorize that the moon once had a molten iron core that generated magnetism via a dynamo effect. Over time, the moon cooled and the core solidified, extinguishing the field. But here's the twist. The field seems to have lasted over 1 billion years, far longer than expected for a small, cooling body. Some newer models propose that precession, the wobbling of the moon's rotation, could have stirred its core longer than anticipated. Others suggest major asteroid impacts could have temporarily restarted the magnetic field. Still, the question remains: why did such a small celestial body have such a powerful and persistent magnetic heart? And does this hidden history tell us something deeper about the moon's inner structure, or its mysterious past? In 2019, NASA discovered a gravitational anomaly beneath the moon's South Pole Aitken Basin, the largest, deepest impact crater in the solar system. Something massive, weighing over 2.4 quintillion kilograms, is buried beneath the surface. Whatever it is, it's distorting the moon's gravity field. Is it the remnant core of an asteroid? A dense pocket of metallic rock? Some speculate it could be a fragment of the moon's own mantle, pushed downward by the force of the impact. But no probe has yet drilled that deep. The anomaly sits hundreds of kilometers below the surface. And then there are the wilder theories, like an ancient alien base, or an artificial structure. Of course, mainstream science sticks with natural explanations. Still, whatever lies beneath the lunar South Pole has no equivalent on Earth. It's vast, dense, and entirely hidden, like a scar buried beneath the skin of the moon. And it may hold secrets not just about lunar history, but about the chaotic violence of the early solar system. Each year, the moon drifts about 3.8 centimeters farther from Earth. While that might seem small, over millions of years, it's a big deal. This drift has been precisely measured using retroreflectors left by Apollo astronauts. As the moon pulls away, Earth's rotation slows, our days gradually lengthen, and tides lose some of their energy. But what's causing this slow retreat? Tidal friction is the main suspect. The moon's gravitational pull creates ocean bulges that tug back on it. Over time, this push and pull causes the moon to spiral outward. But what happens if the trend continues? Could the moon eventually escape Earth's gravity altogether? If so, Earth would lose its most stabilizing influence. Our planet's axial tilt, now stabilized by the moon, could wobble unpredictably, leading to extreme climate shifts and even global ecological collapse. Scientists say this scenario won't happen for billions of years, but the long-term fate of our moon remains an open-ended cosmic drama. Across the moon's surface are bizarre, high-albedo, bright patterns called lunar swirls. They appear like dusty fingerprints or wisps of fog frozen into the soil. The most famous is Reiner Gamma, a swirl that looks like someone painted the moon with a giant brush. The swirls don't correspond to craters, valleys, or any known surface feature. They don't even rise above the ground. What's more, they're often found near areas with strong localized magnetic fields. Strange, given the moon has no global magnetism. Some scientists believe these fields protect the swirls from solar wind, preserving their brightness. Others speculate that ancient comet impacts or magnetic anomalies might be the cause. A few even consider electrostatic levitation of dust as a shaping mechanism. Despite being observed for decades, we still don't know how these lunar tattoos formed, or what they truly are. It's a mystery etched into the very skin of the moon. It looks soft, gentle, like powdered sugar. But moondust is vicious. Fine as talcum powder but sharp as glass, moondust clings to everything. It got into astronaut suits, equipment joints, and even lungs. Apollo crews said it smelled like burned gunpowder. It's electrostatically charged, abrasive, and potentially toxic. But why is it so extreme? Without wind or water to erode its edges, moondust remains jagged and aggressive. It's formed from countless micrometeorite impacts that melt and shatter rock into fine glassy particles. The lack of atmosphere means nothing smooths it out. Future lunar missions must take this threat seriously. Moondust can clog machinery, wear down materials, and pose serious health risks. NASA is even testing special coatings and airlock systems to keep it out. Moondust is more than a nuisance, it's a hostile, alien substance shaped by billions of years of unshielded bombardment, and we've only scratched the surface. Despite being geologically dead, the moon still rumbles. Seismometers left by Apollo missions detected hundreds of moonquakes, some shallow, some deep, some caused by tidal forces. But here's the kicker: some of them were unexpectedly powerful. Unlike earthquakes, which last seconds, shallow moonquakes can last up to 10 minutes. The moon doesn't absorb shock well, it just keeps ringing. What causes them? Some might come from the tidal stress caused by Earth's gravity. Others could be thermal expansion as the moon's surface heats and cools drastically. But there's no clear explanation for the strength and longevity of some of these quakes. More intriguingly, some moonquakes occur near known fault lines, places where the crust is shifting. That suggests the moon might still be tectonically active. Could it still be settling into shape? Or is there heat, or something else, deep beneath the surface? Whatever's stirring inside, it shouldn't be, and that makes it one of the most unsettling lunar mysteries. For centuries, astronomers have reported strange flashes, mists, or glows on the moon's surface, now known as transient lunar phenomena, TLPs. They last seconds to minutes. Some appear as red or white flashes, others as glowing clouds. They've been seen by amateurs and professionals alike, even captured on video. Are these signs of outgassing, the release of trapped gases from underground? Are they caused by meteorite impacts, electrostatic discharges, or are they optical illusions caused by Earth's atmosphere? The truth is, we don't know. NASA and ESA have studied TLPs, but no mission has conclusively explained them. They seem to occur more frequently in certain locations, like Aristarchus crater, one of the moon's brightest and most geologically active sites. Until we observe one up close in real time, TLPs remain a mystery, a flickering ghostlight on the moon's face. When Apollo 12 intentionally crashed a lunar module into the moon, something eerie happened. Seismometers recorded vibrations that lasted nearly an hour. Scientists said it rang, like a bell. This wasn't just poetic exaggeration, it hinted at something truly odd about the moon's structure. On Earth, seismic waves are absorbed and dampened by liquid layers and varied geology. The moon, however, seems to transmit these waves almost unimpeded. That suggests it may be much drier and more uniform than expected. Or worse, it may be hollow. Of course, mainstream science does not support the hollow moon theory. More likely, it has to do with a highly fractured crust and lack of water content, making the moon ring instead of shudder. Still, the phenomenon hasn't been fully explained. Could there be massive internal cavities? Or does the moon's unique formation history create an unusual seismic signature? Whatever the cause, the moon's eerie echo remains one of its strangest and most haunting features. We look at the moon and feel comfort. It's a timeless presence, hanging above us like a guardian, steady and glowing. But now, we know better. The moon is not just a pretty face. It is a relic of chaos, a vault of cosmic memory, and a mirror to Earth's deepest questions. Each of the 10 mysteries we explored reveals how little we truly understand our closest celestial neighbor. From unexplainable seismic echoes to bizarre glowing swirls, from dust that cuts like glass to a magnetic history it shouldn't have, the moon holds secrets not just of its past, but perhaps of ours as well. Some of these mysteries challenge current physics, others hint at ancient forces long gone. A few even raise unsettling possibilities of artificiality, of hidden structures, or of processes we have yet to imagine. But maybe the greatest mystery isn't what's out there, it's what it inspires in us. Because despite its silence, the moon has always made us dream. It made us look up. It pushed us to explore. It reminded us that we are part of something vast and unfinished. And perhaps that's the point. The moon doesn't have to give us answers. Its role may be to awaken the questioner within us, the explorer, the scientist, the poet, the seeker. So the next time you look up at the night sky, remember, you're not just seeing a rock, you're seeing a mystery, waiting to be solved, a story, waiting to be told. And here at Mysterious Universe, we're just getting started. If you enjoyed this journey, don't forget to like, subscribe, and ring the bell for more cosmic mysteries. See you in the next video, where the universe only gets stranger.